PSC has been around since 1986. We're a joint project between the Carnegie Mellon University, the University of Pittsburgh, and Westinghouse Electric Company. We're part of the NSF Exceed National Cyber Infrastructure Project, and as such, we serve a national community of people doing open research in a very broad array of disciplines. We operate a machine room that has a correspondingly diverse set of machines. The most recent of these is a YarcData Eureka appliance, which we've named Sherlock. So the most exciting things happening on the Eureka system in Sherlock at PSC right now center on computational forensic linguistics. Those are with text analytics from David Wools of CFL Software. Also work being done on the Cancer Genome Atlas, on cell and metabolic pathways, and by people in natural language processing and machine learning.
Eureka Appliance is interesting to me because it allowed me to expand on the work I'd done with UCAS. That involved using a Sun T2000 computer with only 8 processors and 4 threads per processor. So when I heard that the Eureka Appliance was going to have 32 processors, each having 128 threads, this excited me immensely because I could see immediately that I could scale up and I could get an even more real-time approach.
We looked for a machine like Eureka, which became the system we call Sherlock at PSC, in response to a call by NSF for a strategic technology for cyber infrastructure system. As such, it was supposed to be complementary to other resources that were available to researchers nationwide. We were after a system that could help people look at complex patterns in big data, to do data discovery, to do interactive real-time analysis, and to really find the relationships that they couldn't find on other HPC systems or other big data or Hadoop systems.
Any organization which has got a large quantity of documentary data will find Eureka Appliance useful simply because it allows you to find out what's in there. You don't actually have to ask it any questions at all. You can simply say, tell me what is in this document or this set of documents, and it will do that. It also will show you the linkages between those documents, and these are far more complex. A regular index is indexed by word by document. So you can find that there are 18 million instances of the word Ethernet on the web if you ask Google. And you can find that maybe there are 25 million examples of an Ethernet controller. But to actually get it down to which ones are useful to you is far more difficult for you because you don't actually know what all the words are. So by letting the program find out how many things it could be looking for, doing the matching for you, then what you end up with is a very relevant set of documents which are guaranteed to contain material like the document you started with. What the Eureka Appliance enables me to do, which I couldn't do before, is simply to work on a much larger scale. So the idea behind this is to use the computer to say what is useful in terms of terminology which can be linked to each other and what is not so useful, and so can we get rid of it.
The key here is having big data problems where one wants to find subtle relationships, especially interactively, do it even remotely from one's desktop, using Eureka as an appliance to do data discovery.
What we've discovered is that once the software is on the appliance, then people who are unfamiliar with coding or have no knowledge of coding at all will be able to explore their own data in ways that they would want to. They are not restricted to looking for what they know is in there or what they think they know is in there. They can simply find out what is there.
Many groups have large complex data that just aren't amenable to either desktops or their traditional cluster or supercomputing resources. And that's where the Eureka architecture and machines like Sherlock add unique value.